Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 16, the most famous ratio of all. Its name is not Rudolph. Okay, here we go. This is my compass. It says here, opening exercise, using a compass, draw a circle like the picture to the right. So if I want to copy this circle, and I want it to be the same distance from C to B in my circle, I can copy it using the compass by simply moving the point to the center, like so, and then extending this out to the edge. Okay, now let me pick a different color besides black. Make it red. Okay, so now I have this pencil right on the line. Let me just undo so it goes right back. Okay, so now if I move this, see how the red line is right on that circle? So if I now move my compass over here and put my circle center, it will be right here. So I'll put a dot there just so you can see it. Okay, that will be the center. And then when I move this around, like so, there is my circle. So now if I drew a line segment, from here to there, try that again, it jumps a little further. Okay. And let me just shorten this just a little bit. Okay, best I can do right there without losing simplicity. So if I labeled this C is the center of the circle, C is the center of the circle, and B is the radius of the circle, the distance between C and B is the radius of the circle, then I'd call this point right here B. So this is identical to this circle, and CB is the same length as this C. So that's how we draw a circle using a compass. So now it says, write your own definition for the term circle. So see if you can come up with your own explanation. If someone asks you what is a circle, how would you explain to them what a circle is? So pause the video, try to answer this on your own, and then we'll come back and see. Okay, so here could be some varying responses. You might say it is round. It is curved. It has an infinite number of sides. Does it? The points are always the same distance from the center. Analyze their definition showing how other figures such as ovals are also round or curved. Okay, so this is what it's saying what to do here. What's special about the compass you use, that kind of thing. So the distance between the spike and the pencil is fixed when drawing the circle. Okay, so now that I've said that, the distance between the spike and the pencil on the compass is it fixed when drawing the circle. So see if you can define it a different way now with that statement. Okay, so now part C says to extend segment CB to a segment AB in part A, where A is also a point on the circle. So now I need to go back and get my compass. Or not my compass, but my ruler. Where is it? Oh, there it is. I made two. Hang on. Bring this down. So where could A possibly go if it's going to be on the circle, but also on that same line CB? Okay. If I draw it here and I come down like that, that's not a straight line. That would be an angle at the point center. So the only possibility would be to draw a line this way. And now I would have to name this point right here A. So that's what it asked me to do, just down here on part C. So I extended segment BC over to the other side of the circle, put a dot there and called it A. The length of segment AB, the whole thing, is called the diameter. So this is the radius, and the whole thing is the diameter. Okay. The length of the segment AB is called the diameter of the circle. The diameter is blank as long as the radius. Well, the radius is this red piece, and it goes from the center to the edge, and this goes from the center to the edge. So these are two pieces that are equal. So if this was x and this is x, CB equals x and AB equals x plus x, which is 2x. So the diameter is 2 times as long as the radius. Okay? E. Measure the radius and diameter of each circle. The center of each circle is labeled C. Okay, so now this is a measuring activity. So I'm going to bring in my ruler. Switch to this one if I can here. I'm going to try to make this line up the best I can. So usually we measure with inches in the United States. Okay, so if I measured in inches, we're going to have to deal with fractions. If you measure with the metric system, they're in tenths, a little bit easier. So if I measure everything in tenths, centimeters or millimeters, okay, this went out to 3.5 centimeters or 35 millimeters. So it says measure center. Okay, so it says measure the radius and diameter. So I measured the diameter and it came out to be 35 millimeters. So AB, so I'd say diameter, let me undo that. Diameter AB, I should say of. It is diameter AB. The diameter AB is 35 millimeters. The radius AB is, alright, so I'm not going to measure it. I don't have to. What do we know about the diameter? The diameter is twice the radius. The radius is half of the diameter, so half of 35 is 17.5 millimeters. Okay. Now we're going to measure the next one. So let me rotate this over here until it's parallel. So now we're doing EF. Approximately that, I'd say that's 46. So I'd say diameter EF is 46 millimeters. Radius EF, I'm not naming these right, I just caught that. Radius EC, E to C, so I'm going to, this is radius AC, my apologies, it's half of 46, which is 23 millimeters, okay? And now I'm going to do the last one. This one doesn't have a line, so we have to make one. So first let me draw a line segment from edge to edge going through the center. And then I'm going to move it down and measure it. And it's about, let's just say 70. So the diameter and this was A, B, C, A, B, E, F, how about G, H, call this center C. Okay, I don't need this anymore. Get it out of the way because it's grabbing my line. I'm going to try to draw the H. So call this GH, and this is center C. So diameter GH is 70 millimeters. That's what we measured. And then the radius is half. Radius GC is half of 70, 35 millimeters. Okay? So this is just getting you to measure and realize that the diameter is half of the radius, or the diameter is twice the radius, and the radius is half of the diameter. Now it's asking us to draw a circle of radius 6. So in order to do that, I need a ruler first. So in order for us to draw a circle with a certain diameter, we first need to draw the line segment that goes from 0 to 6 centimeters on a ruler, which is from here to here. Okay. Approximately. I went over just a little bit. Kind of follows my pen. Let's try that. There. 0 to 6 is right there. So the first thing I drew was my center. Now I need my compass. And I need to put, so where's my center here? That's the next thing I need to find. So I need to bring my ruler back, because these are the two endpoints. So I'd have to measure 3 and put a dot at the center, which I'd forgotten to do. So now let me go get my ruler back. Put it back here at 0. And put a little mark at 3, and that's going to be the center of my circle right here. So now I got that green dot at the center. I'll move this so it's right on that dot. Move my compass out to the end. Draw a circle around. There is a circle. Now this is a diameter of 6. And now I'm looking, it says draw a radius of 6. Okay, so this is a diameter of 6. So there's one circle. So I just wanted to show you what the difference between two circles are, with one a diameter of 6 and one a radius of 6. Okay, so this is a diameter of 6 in this circle, but if I brought my compass out like this now and drew a circle with this diameter, watch how big my circle is. Okay, and it's off the page. So this would be a circle with a radius of 6. Okay. Mathematical modeling exercise. The ratio of the circumference to its diameter is always the same for any circle. The value of this ratio is circumference, and circumference is distance around. So if I took the circumference, picture taking this circle here, say that was a rope around something, cut it and roll the rope out, or take a label off a can and lay it flat, the length of the label would have been the circumference of the can. And the circumference, the value of this ratio is circumference divided by the diameter. It's called pi, and represented by the symbol pi. Okay, so the circumference around divided by its diameter equals pi. Since the circumference is a little greater than 3 times the diameter, pi is a number that's a little greater than 3. Use the symbol right here, it's a Greek letter, pi, to represent this special number, and it's spelled capital Pi, is a non-terminating, non-repeating decimal, and mathematicians use symbol pi to approximate representations as more convenient ways to represent pi. So pi is approximately 3.14 or 22 over 7. Now, I really don't like using this as a approximation, simply because pi is an irrational number, and 22 over 7 or 3.14 rounded is rational. So if they're looking for an exact value, you always use the pi symbol. If you're looking for an approximation, you do round. But I generally don't like to use 22 over 7, so I prefer the decimal. The ratio of the circumference to the diameter is pi, and pi. The ratio of the circumference to the diameter and pi to 1 are equal. Okay, circumference of a circle is pi times diameter. So we're going to start using that formula to find things about the circle. The following circles are not drawn to scale. This is not 21 centimeters, 91 feet, 35 and a half meters. It says find the circumference of each circle. Use 22 over 7 as an approximation for pi. So if it says to use it, then do that. So anyway, we have 21 centimeters. So again, up here, it says pi is circumference divided by diameter. So 22 over 7 equals the circumference over the diameter. Okay? And it says find the circumference. So right up here, pi equals circumference over diameter. Okay, so pi, the approximation 22/7 equals circumference over the diameter 21. We cross multiply, so we get 7 times c, which is 7c, equals 22 times 21. Okay, so 22 times 20 is 440. It'd be 462. Okay, so if I divide 462 by 7, then I find my c. 7 times 7 is 49. 7 times 6 is 42. Remainder 4, and it is 66. So the circumference would be 66. Okay? So again, this is just repetition. See if you can try these on your own. Pause the video and come back. Okay? Now let's take a look. 22 over 7, which is our pi approximation, equals circumference over diameter. Cross multiply. 22 times 91. Okay. Okay, so I brought my calculator in because there's some crazy values that we want to calculate. So 22 times 91 is 2002. Or feet. Always look at what our measurement was and use the same. This is 2002, is that right? And then we have to divide by 7. Okay, and then C equals 286. Okay, so the distance from here all the way around, if I took that string and straightened it out after going around once, it'd be 286 feet long. Okay, the next one, 22 over 7 equals circumference over diameter. Now be careful, this is radius. And it's 35 divided by 2, so the whole thing would be 35, not half of 35. Cross multiply and get 7c equals 35 times 22 770 divided by 7 is 110. So we get 770 divided by 7. So C equals 110 meters. Okay. B, the radius of a paper plate is 11.7 centimeters. So if I drew a picture, center, draw a line out, this is 11.7 cm. That's our plate. Find the circumference. Use 3.14 as an approximation. So I'd say 3.14 equals circumference over diameter, which is 11.7 times 2, which is 23. Think of this as over 1. Cross multiply, and C equals 3.14 times 23.4. 3.14 times 23.4 equals 73.476 centimeters. There's our approximation. Now, then always go back and read the question. Many of you do not do that. Find the circumference to the nearest tenth. So this is the 100th position here, which determines rounding up or down. 7's more than 5, so that 4 is going to become a 5. Round up. Rounded to the nearest tenth, that plate is 73.5 centimeters. Part C, the radius of a paper plate is 11.7. Find the circumference to the nearest 100th. Use the pi button on your calculator as an approximation for pi. This will be much more accurate. Okay, so pi over 1, if you will, equals circumference over diameter. And the radius is 11.7. So this diameter is 23.4. Cross multiply, C times 1 is C, equals 23.4 times pi. So we just write it like a variable, 23.4 pi, and C equals. Now it said to use the button on your calculator. You just have a regular 4-function calculator, you will not be able to do pi. So mine has that. The pi button, if you look really closely, it's hard to see here, but it's this blue symbol right above my caret button. So I have to hit the second button and then this button to get pi. So it'll be 23.4 pi. So see on my screen, 23.4 pi, and when I hit enter, it will multiply 23.4 by 3.14159, blah, blah, blah. And that is 73. Now, then I down to the nearest 100th. So I look at the 1,000th place. 3 is less than 5, so I would just cut off and end there. So it's 73.51 centimeters. A circle has a radius of r centimeters and a circumference of c centimeters. Write a formula that expresses the value of c in terms of r and pi. Okay, so we want this to say c equals something. Well, we already know that pi equals circumference divided by diameter. Okay, and let's go back and look again. Circumference over diameter is the ratio for pi. So pi equals c over d. This said to solve for c, so c is being divided by d, so the inverse, remember when we have to move stuff across equal signs, we do the inverse? This is being divided by d, so the opposite of division, or the inverse of division, is multiplication. So I need to multiply both sides by d, and then these cancel, and I'm left with c equals diameter times pi, or pi times diameter. So let me write it like that, because that's the actual formula. C equals pi. Okay, and I really shouldn't use capitals, but we'll talk about that when we get to the formula. The figure below is in the shape of a semicircle. Semi meaning half a circle. A A semicircle is an arc that is half of a circle. There, they gave us the definition right there. Find the perimeter of the shape. Perimeter means distance around. So I know this piece right here is 8. Okay? What I don't know is what this arc around here is. So I need to add this to 8 to get it all the way around. Okay? Use 3.14 for pi. Find the perimeter. Alright, so we need to find the circumference. So circumference equals pi times diameter. I'll use a lowercase now. And then I substitute in. Circumference equals pi times 8. So C equals 3.14 times 8 because they told us to use 3.14 for pi. So please follow the directions when you're answering questions in this section. Sometimes it'll say use 3.14, sometimes it will say use 22/7, sometimes it'll say use the pi symbol. 8 times 4 is 32, 8 plus 3 is 11, 8 times 3 is 24, plus 1, 25, 2 decimal places. Okay, it does not say to round anywhere. It's 25.12. That would be the entire circumference all the way around. If I had a full circle, I need to divide this circumference by 2 since it is a semicircle. So 1/2 the circumference equals 1/2 of 25/12, which is 1, 2, 5, 6. 12.56 meters. Now I need, now that is from here to here. And I need to add 8 meters for the diameter to that circumference portion. And I get a final answer of 20.56 meters. And that is my perimeter. Okay, so this page is giving us all of the relevant vocabulary from this lesson. And here's the definition of the circle. Given a point O in the plane and a number r that is greater than 0, the circle with center 0 and radius r is the set of all points in the plane whose distance from the point 0 is equal to r. All that's basically saying is if you have a point, all the points that are on the circle are the same distance from the center. Then they explain radius of a circle, the diameter of a circle, the circumference of a circle, a semicircle. So this is all really important review right here for you from this lesson. So please review this relevant vocabulary. I will be using it. That is the end of lesson 16. Do your problem set.